Hey everyone, welcome to our next video for week 6, and we're going to talk briefly about linear equation. So this video, we're starting our discussion on linear regression and correlation. So we are going to be pulling some skills from algebra. So this video, we're going to do a quick review of some linear equations, and in the next video, we'll do a quick review of graphing in 2 dimensions and scatter plots in preparation for next week. So in chapter 12, we're going to be looking at bivariate data, which is 2 variable data, and trying to determine if there is a relationship between the 2 variables. Linear regression fits bivariate data to a line in 2 dimensions, and correlation measures how strong the relationship between the 2 variables is. So this week, we're reviewing 2 important tools that we'll need to do linear regression and correlation next week. In a previous math class, you probably learned about slope-intercept equations of line. So the general form for a sloped-intercept equation is y equals mx plus b. Y is the dependent variable. It changes in response to x. M is a constant, it's a number value, and it represents the slope of the equation. X is the independent variable. As a statistics researcher, that's the variable we have control over. And B represents another constant, which is the y-intercept of our. Remember that slope is a measure of the rise over the run. It measures the tilt of the line. And we calculate it by subtracting the y values and then dividing that by the difference in the x values. Slope can be positive or negative. Positive means as x gets bigger, y gets bigger. It tilts up like a hill when you read your graph from left to right. A negative slope means that the line tilts down like a slide when you read your graph from left to right. The y-intercept is the point where that line crosses the y-axis. And we represent that as an ordered pair 0, b. And b is that y value where the line is crossing the axis. All linear equations should have a few things in common. One independent variable and one dependent variable. Both variables have no exponent, or they have an implied exponent of 1. So no squares, no cubes, no square roots. The variables are on the same side of the equation. They may only be connected with addition or subtraction. So x plus y is okay. That's a linear equation. X times y is not. And the equation produces a graph that is a straight line. And that's how we know it's linear. Slope-intercept form is one of many forms for a linear equation, and it meets these requirements. You're going to notice in your textbook and many statistics textbooks, instead of y equals mx plus b, we're going to do y equals a plus bx. So in this case, we're basically taking those terms as we see them here, and we're reversing their order. So the y-intercept comes first. That a now represents the y-intercept. And the b in front of the x now represents the slope. So the pieces from slope-intercept form are still there. They're just now backward. So let's look at some graphs. This first one, I can see it's a nice straight line. So that's definitely linear. One of the properties of a linear graph is that it has a constant slope. So if I look at how I'm getting from one point to the next, to get from -2, -3 to -1, -1, I have to go up 2 and forward 1. To get to from this point to the next, I have to go up 2 over 1. So that constant slope defines a line. The second thing is I can see where this line is crossing the graph. I can see it's crossing right here at 0, 1. So I know two things. I know that my slope is 2 over 1, which is 2. And I know that my y-intercept is equal to 1. So we could actually write an equation for this line in slope-intercept form. It would be the slope times x plus the intercept. Or if we're talking about linear regression and correlation, I just flip that order, 1 plus 2x. Every graph that is linear will have a similar shape. So this one, we can see it has a different slope and it crosses at a different point, but it's still a straight line. Nonlinear is anything that is not a straight line. So for example, here we've got a polynomial, 2 peaks and a nice smooth curve. This one is a nice quadratic. It's like a parabola here. These are nonlinear. You can fit data to a nonlinear curve, but we're not going to talk about how to do that in this class. The most common process you'll use is linear regression, where we're trying to fit data to a line. If you play with programs like Excel, they will give you the option to try and fit to a line or to a nonlinear curve. So let's practice writing equations. So for this example, it says Aaron's word processing service does word processing. The rate for services is 32 per hour plus the 31.50 one-time charge. The total cost to do a customer, sorry, that's worded a little weird. The total cost to a customer depends on the number of hours it takes to complete the job. Find the equation that represents the total cost in terms of the number of hours required to complete the job. Whew. Sorry, words are hard today. So they're asking us to find an equation. So we know we want to write an equation. We know the easiest way to do that is to use slope-intercept form, y equals mx plus b. We know that the y-intercept is where the line crosses the y-axis. It's also what we call the initial value, which is y when x is 0. And then we know that m is the slope, which is rise over run, which is the change in y over the change, and I cannot write today, I am so sorry, change in x. So probably the first thing we should do is define x and y. And we know that x is independent variable, the thing we have control over, and then y is the dependent variable that changes in response. And our two variables are total cost and number of hours. And thinking about the potential relationship between those, as customer, we have control over the number of hours. We don't have control over the total cost. It's number of hours determining total cost, not the other way around, total cost determining number of hours. So number of hours is the independent, that's the thing that's changing, and then total cost is going to change in response. So more hours will result in more cost, not the other way around. So first thing, looking at y and x, I know my slope, which is y over x, should be cost over hours, because y is cost and x is number of hours. Looking through that question, I see a quantity that is cost per hour, $32 per hour. So I have a sneaking suspicion that my slope m is probably $32 per hour. My y-intercept is an initial value. And I can see it says the rate for services is 32 per hour plus a 31.51 time charge, meaning just to order the service, regardless of how many hours I spend, I have to pay 31.50 up front. So that's that initial value. That's that base charge. And then $32 for every hour that the service takes. So my initial value, or my y-intercept, is going to be 31.50. From here, all we have to do is write that equation. Y equals mx plus b. We're going to substitute in our values for m and b. So y equals 32x plus 31.50. There is a keyword here that's an important clue that we're looking at a slope, and that's that word rate, and often a keyword that goes with it, per. Rate indicates that we're looking at a ratio of change in one thing versus change in another. And we know that's the definition of slope, change in y over change in x. And that keyword per means we're looking at a fraction, something divided by something. So both of those keywords tell me that I'm looking at a slope. In this particular case, this one-time charge implies that it's a flat initial value that comes at the beginning, and that keyword tells me I'm looking at a y-intercept. So if we're writing equations based on word problems, there are some keywords that we look for to tell us whether we're looking at a slope or a y-intercept. The upside is when we start working on this next week, our calculator is actually going to be finding those values for slope and intercept for us, but it is important we recognize what they represent. So let's try another one. So this one is interpreting equation. Says Svetlana tutors to make extra money for college. For each tutoring session, she charges a one-time fee of 25 plus 15 per hour of tutoring. A linear equation that expresses the total amount of money Svetlana earns for each session she tutors is y equals 25 plus 15x. What are the independent and dependent variables? What is the y-intercept and what is the slope? Interpret them using complete sentences. So let's start with the beginning of that equation. There's two values that we see. So we see a one-time fee of 25. And then we see plus 15 per hour. And we learned last time that keyword per is likely telling us that this is our slope, m. And that key phrase one time is likely indicating that this is our y-intercept b. Also, looking at this equation, we kind of recognize that it's similar to slope-intercept, but backwards. So we can rewrite this as 15x plus 25. And then it's really easy to see that our slope is in front of the x where it should be, that our y-intercept is the constant at the tail end where it should be. So they ask us then, what are the independent and dependent variables? So what do x and y represent? What is the y-intercept and what is the slope? So looking at the statement, It says linear equation that expresses the total amount of money Svetlana earns for each session that she tutors. So I know that this equation is outputting a total amount of money. So the first thing I know is that the dependent variable, which is y in our equation, represents the total amount of money earned. And then we need to describe the independent variable, or independent variable x. And then we look back at the problem, and it says for each tutoring session, she charges a one-time fee plus $15 per hour. So that independent variable that's determining how much money we make must be the number of hours that she tutors. So we're looking at the relationship between the number of hours tutored and the total amount of money that Svetlana earns. They then ask for the slope. So we know that the slope is the $15 per hour. And the y-intercept is that initial value of 25. This interpreting equations is going to be more relevant next week because, again, our calculator is going to spit out that slope and intercept for us, but we need to be able to describe what it represents and how it relates to the situation that we're describing with our linear. So for this week, the homework for 12.1, you're just looking at graphs, describing shape, and then making connections between the linear equation, the slope, the intercept, and the variables. If you have any questions on what you saw in this video or any of the algebra skills we're using this week and next week, feel free to contact me via email or text message, or drop by my office hours Tuesday, Thursday, Saturday. I hope you have a great rest of your week, and I will see you in our last video.